the same anymore. You can't do it.
Yes. The top
You have to make the bottom the same as the thing.
minus.
How do you make the bottom the same? You can only do it 5 times. Correct.
Done?
Oh, scramble thing. Equals. Yes. Oh. Okay, to make them the same, right? I'll show you. Basically, you have to make the bottom the same, right? So they cannot be 2 and 3, they must be like the same number. Like if they are 2 and 3, I can make them into a number 6 or 2 and 3, 6. So here I times 3. Here I look like 3. So it becomes 3 over 6.
Anything to ask for that?
So it goes to 6 and 2. See, now the bottom are the same.
No problem.
Then you can do it. Okay, I'll show you another example. It's very different. Okay, what about this?
Because there's no space.
Oh, okay.
Oh. Okay, let me go to this 102,004. Yes, you see, here is 4, right? Remember, if you want to add or subtract, the bottom must be the same. Are they the same? So we have to make them the same. You see, there's a pattern. If here is smaller, here is bigger, like having the smaller equals to bigger. So how can I make 2 into 4? How can I turn 2 into 4?
Oh, so you're done it already, right?
I also do.
Always use
PD.
Okay, how do I turn 2 into 4?
That should be a sensible idea. Okay.
Correct. Then it's just times 2 but must be on both bottom and top. After you do this, it becomes this. And you see, now it's the bottom the same, then you do this. Here's another example. And we get used to the
Let's look at part A first.
How about 1 over 3 plus?
I hope you notice the fuse between M. So normally, most of the time when you see this question, it has to do with the fuse. Alright, so
I'll make sure the bottom is the same.
basically check. Usually is to check the current. Alright,
You can try this.
and versus the fuse.
How do I do it? Hey, do you see that? Bottom sound the same.
So in other words, your calculation must involve calculating the new current.
Get the bottom first.
Is it more than or less than the fuse? Okay, this is a very standard kind of questioning method.
Ah. Times 1.
Oh,
Ah, so you can times 4 both top and bottom. Then it becomes 4 over 8 plus. And you see, all the bottoms are the same, then you can just plus.
Right, they did tell you that it's a parallel arrangement. So are you able to calculate the currents, the new currents?
So you always times it.
And find out first. Let me just quickly go to the against.
Okay. So it becomes 1. There. I'm sure you right. And right again, one. So it becomes 1. 1 becomes 1. 1 times 2 is 1 times 2.
no.
Right up. You're right, yeah, you're right. You write the whole thing. Then the bottom is 1. Then you write it.
Oh, yes.
Right. 6 at the bottom. Hey.
Go ahead.
Becomes. Yes. Everyone.
What's more than equal 6?
大是收咯，我係大識咩？啱你個 four times equal six，我就先定你哋咧。Or 8 fell all the way to 6 fell 18 all the way anywhere they have the same number. 啊，multiples of 4 咧18啊
18.
You're right now, multiples of 4 18 is it?
I don't know.
Right now. Yeah, this one. Okay, times 2, right? Top becomes 2 times 2 is. Oh, that's it.
What?
What does it mean? What do you mean? Very easy, right? Just
You agree that? Next question. So what is equals more than 6?
memorize, memorize.
Cross? No.
There. I saw that. I saw. Okay, you see that's another one that you means. Okay.
Well,
Obviously, have a single difference because minus all.
oh, this is my.
What they do.
Oh, this is.
So one, because of minus. You cannot find the similarity when 6 and 4. So what times what? I'll give you an example. 1 over 2 plus 1 over 3. Hey, Ian, George, listen. I show you the easier one. Some of the numbers, 2 and 3, not the same. They don't have the same, right? At least them up. 2, 4, 6, 8, blah blah blah. Then 3, 6, 9, 12. How do they have in common? 6, 9, 6. Oh, I thought it's 6. Then I thought it's 6. I didn't know. How about over 3 to 6? Okay, yeah, that's 2. And how about over 2 to 6? 3 1 so beside by 3, that's 2. So they have different things to make them the same. Oh, they can have different things. You don't have to have the same thing, you have different things. That's the trick. Beautiful, slightly different. But I say for 4, they go for 6. Wait, what do they do?
How you put the this is 4? Because 4 times 3 is 12 and then 3 times 3. Wow,
Wait, this time already, right? So what do they have in common? So like, well, so how do I make 4 equal 12? What do I times? Okay, and how do I make 6 equal 12? Different is a thing.
plus times 4.
Yeah. Different. As long as you make the ball the same, that's the thing.
How about this time?
Oh, I got double. Double. The bottom don't touch, right? Now the multiples of 4, multiples of 6. You did it already, what?
Joey, do you finish everything?
Okay. Three times 3, right? So you times 2,
Nope. Okay, come. Work on them.
Hey, stop.
Just now, Bernice was asking about this. 3 part B. Using suitable calculations, whether this would be a sensible idea. Now, in this case, since the circuit involves a fuse, normally your sensibility means that you want to check your current versus the fuse rating. Okay, whether the rating has been exceeded or still within it. Okay, that's in the normal format of how they want to pose the question. How? Bernice, okay, and should be quite doable. Have you done this, Bernice? No,
Make the bottom the same, right? See all the bottom.
actually there are not many there, right? Yeah, okay, just finish off question 4 and 5. All of them are quite doable and I would say rather standard questions.
Circle. Only four, right? Then we only got 6. Or make 4.
What? How do you do this?
Think ounce lah, only one also. Release the denominator. How do I make 1?
How do you do this? How do you do this?
Think.
How do you
How do I make 1 decrease? Divide plus minus.
How do you do this? Got here. Just got.
4 times 1 is 9.
Wow.
Think the same as this, So 3 times 3. Oh, really? Yeah. And how do I consider?
The same thing.
Yeah.
Oh, I do.
Yes.
What?
How do I consider?
Oh.
It's very good. Hay một cái sai đi à? Okay, I'll see whether it's correct or not. If you can do it, very weird. This one is the kind of question is this how it's such. It's not. Then you list out what times. It's 10 out. It's the same. It's the same. It's the same. It's just okay. No different. 3 and 4, right? You tell me the time there or 3 also.
8, 9,
Okay, then now for 4, now for 4, right? Okay, coming.
8, 12. There.
What do they have in common? Chinese. So 3 times 1 is this. 4 times 1 is this.
Is it 3 and 12?
Yeah, 3 and 12. How do I like 3 to count?
I don't know.
Oh my god, you can do it. Hold on, so fast.
Oh.
The same as the previous one, the same. It's the same.
I'm just not know that.
It's the same, it's the same.
Nope. I got to try this one.
Yes, it's the same as this 4 and 3 now.
I hate this.
It's not really that show. Is that all? This is tricky.
Oh, how you make 3 and brush? I give up. I'm gonna skip this one.
I'll try.
Oh,
This stuff, multiple of 3, multiple of 4.
3 and 9.
3 and later, 3 and 4.
I don't know why you put the outside of pink.
我看 U 啊，这。Okay, this stuff, you need to be a number of 4. It's like 3 or 4. It can be 3.
Question, Bernice?
Cannot very big without. Need all like different things now, cannot be the same. Okay. So now it's 3 and
Question?
so now it's 3 and 4, right? What do they have in common? See it again. So okay, you circle it. Okay, now the same thing can become 4 and 3 become.
The last question is.
What? There you go. That's one thing to move to.
Oh, wait.
And
How?
Ah, he's not getting that, not really zero. Okay, this one you see the pattern 3 and 9, right? You see something? From pattern 3 to 9? This one is the easiest that you will It's easier than all the rest. Yeah, I don't think so. It's really quite okay, 3 and 9, right? How do they have to say again? 3, 8, 9, 7. Yeah, then what do you do? How do you do the 3? Times 9. How do you turn 3?
That's 3.
So you don't need to change one side.
Three. Then this one is times 9.
Huh.
This one is times 9.
Like 3, right? So become 9 here, right? The bottom is 9, the bottom is 9. Let's see the change of the time.
Change one side.
Very what you want.
Let's
Okay, you times 3, right? Become 3 times 2 is. Okay, then you write again now. You write again now. 3 times 2 is. 2 is. Here we go. 3 times 2 is. I write for you. 3 times 2 is.
One bigger is.
The bottom 3 times 3.
No, but it's finished.
9.
No.
Okay, just write again. Okay, just count again. Yes, go through. And see, on the same right, do it. So easy. So what is it? What is now 9? What is that?
Questions?
Equals to? Yes. Oh my god, can you take it slow? You're too close. You're wrong. I'll do it. Okay, so you find it right? Okay, let's rewrite slowly and all this. Then bottom 3 times 4.
It's not the bigger group.
You wait.
That's one. You want some.
1, 2, whatever you do wrong thing you do again. 3 times 4 is. Okay.
Like what in a so the one small.
Cái này là phù không phải không đây là
Smaller. Then
không this one
it's less that is
gì con nó phân biệt một
another second one. And it's
hai điểm rồi
wait, what? I think what's it?
quay lại đi kìa or is the bottom of the same minus. Okay, I'll give you an example.
Just go through this one.
If you know the way, the way
I don't think one. Often do.
okay, now we have a box in the middle. Have you learned this?
Yes.
Oh, so what is one? What is one? Okay.
If I say that by
Yeah.
Right.
You can.
oh my God, you just need to
Uh,
so if this guy is so good, but I don't know.
And all that. Okay, okay. Always. I move on to next. Okay, let's see what's next. What is?
What time I turn on the sunlight? But because my is not very big, so I disconnect.
Okay, I'll give you an example. Or actually, you have this, and you have those two. What I mean? Okay, which one is your 4 or 3?
Oh,
So this one is this one.
I don't know.
Pointing C, small big to small big, one big. Okay. Then what about? What about 6 and this one? Okay, this one, 1 or 2.
My one.
Yeah, big is small. Okay, now we try to do funny thing.
Oh,
Fraction. Okay, beside. 2, 3. Which one is smaller? Which one is smaller?
that one.
What? Okay, if you're confused, convert the bottom to the same thing. They are the same, so it's like how can I make them the same?
I have 4.
Huh? So what can you do to make them the same?
I know 8.
Okay, think easier than 2 number.
No,
How?
I know.
Okay, then just all this becomes 4. Now if you look at this, now the bottom there are 6. So which one is equal? So bigger. Now try.
Wait, 5.
Just think. Very
Oh my god, I don't know.
interesting.
Oh, but these are constant.
It is.
It is not steady.
They have the same, the bottom the same. They are not the same.
That's 3.
Honestly, we'll make them the bottom.
Wait, we can make up.
The bottom the same lah. They can see. Not the same, we have to see.
Huh?
If we have 1, 3, yeah, I'll just take it.
Is chem or physics first? Should be together like for you. So that means your this will be for you. For now, for you it be together. This paper 3, I can't remember whether you're taking paper 3 or 4 though. 3, 3. But there's also paper 1. Paper 1 is on another day. And for you it's together. There's no separation at all. That means half will be physics, half will be chemistry. Yeah. Yeah, lah, why not? Before that, let me just confirm. You're thinking, yeah, correct. Then this is 1 hour 15 minutes. Then paper 1 is 1 hour 15 minutes as well. Paper 1 will be your MCQs. Right, is that what you were told?
No, they didn't give
Yeah, you have to figure it out. But make sure you check your dates and times clearly. You mean your paper is on a different day? It should be this one, 2nd of October. Correct, right? Which one? Paper 3. That's all right. Paper 1 and 3 only, right? For you.
You cover the same first. You cover the same first.
This is 7, this is 4.
Right. It was
And
that's only 7 and 4.
what are we talking?
They had the same common number.
Ah. Oh.
And write sometimes tables.
Ah. It is just like.
Yeah, I don't think any very few schools should be offering this paper fund.
Like this. So what do you think you want? What is 3 or 5? Take 1 take 10, right? No, just right beside now, right beside. 6, 10, right? You know, you don't need to 6 or 4. 6 or 4, you don't need to. Oh,
When is your English?
I don't think it's 9, is it?
9, 11.
yes.
I'm not doing good. This is hard. I'm not doing good.
The
I'm not doing good.
for English or possible.
The written one. 9. 9. Okay.
No,
9.
it's
I can buy already.
September 11. Oh, okay. September, right? Should be September.
3, 5, 4, and 10.
Or up point 10, okay.
September.
Okay, how do I make the bottom the same?
This one, right? But it's 12.
Yes, 5 2 is 10. Times both
then
and
12
1.
is English.
Always right again.
Okay, so SS is first, huh?
So,
SS 11, yeah. 11 of September. So English is the 12.
Big small right? Big big.
There's the 2 weeks.
but how do you put it?
Paper 1 and paper 2. Portion size.
The same.
But we never specify which.
Always make the bottom the same. Once you make bottom the same, everything is.
Because I read based on what they give us.
But have you taken your, that what do you call that? That piece of official paper from MOE? Haven't. That one should indicate whether it's paper 1 or paper 2. So this one is just your teachers told you that.
Like they did give us the pages, but it's not the official one. But the
What number is 1?
Then who printed that piece that you were given? Your school. Oh,
the school give one out, but I'm not very sure.
should okay. That's weird. But your English, that's one paper. But this LC, LC, then 15. Yeah, correct. 15.
There's 18 in London.
18. 18 is what? Mother tongue. Oh, you haven't taken mother tongue yet. Oh, is it? Your one is not earlier. Okay. So that's your one. Okay. But all right, that means you complete everything by about early October.
Right, then it's our last before.
Then, which is what subject?
And then our 11.
Oh, okay. Actually, nothing much is left already. SS.
Still has 4.
You're not taking A math, huh? No.
So,
Oh, I got it.
Yeah, for science, the last is 4th of October. Okay. Finishing soon. Okay, come, let's quickly go through this.
Never change.
Right, come. Number 2,
No longer
minimum, maximum current and the average power of the refrigerator. All right, should be quite doable. But Bernice, what do you get for maximum current?
Oh, correct.
Just write the sign.
I got the 1 out.
And I'll check it.
1 out of 3, yeah. Okay, but try to leave it in decimals rather than fractions. Yeah, for physics, they don't like fractions. Chemistry as well, they don't like fractions at all.
Oh, the same.
So yeah, I see you got that. 0.333 and here. And what's the average power, Bernice? One.
Hey, I will show you an example.
Why have to listen?
Yes.
What?
Average power that is based on your 24 hours of usage. And of course, based on this value, 0.39 kilowatts hour. So 0.39 divided by time, 24 hours. You should get your power in kilowatts. Now, of course, the question didn't ask you to convert to watts, but so it's up to you. If you really want to leave it in kilowatts, you should still get your marks because the question didn't specify what are the units for the power. Okay, all right, yeah, pretty straightforward using of the formulas. This one is slightly more tricky, but still doable. Name the wires P, Q, and R. Joey, what is Q? What's P? Yes, P is the lines. Make sure you know that. The fields and the switch are there. Make sure you see that. Switch and field. What is Q, Joey? Q is off. It should be neutral. All right, you know why? Because look at carefully from the line, it goes into the appliance, and from the appliance, it completes the circuit and go into Q. So P is the line, Q must be the neutral. Notice the complete circuit here. Can, and importantly, R is the earth because matter case. You must be sensitive to the word matter case. Earth is always connected to the metal casing. So this will be the earth, which is R. Bernice, all right. Okay, now part B, you have a new appliance, 3 kilowatts and 2 kilowatts. All right, so you're supposed to calculate the current. What current do you calculate, Joey?
啊，
So what's the total current?
My brother one.
Guys are interested in the total current, yeah? Okay, about 8 ampere.
I have my brother bought that thing, but not but
12.5 for the 3 kilowatt heater, 2 kilowatt you should get. Remember, they are in parallel. That means you must add the individual currents together to get the total current. So, yeah, 20.8.
Anybody knows how to do it?
Again, Bernice, do you get it? So you have to calculate the individual currents first for each heater. One is 12.5, one is 8.3. Add them together. Remember, parallel arrangement. You can add and you get the total current 20.8.
So the identification to do the law become dash now. That's how divide become their expression. What if I put 2 over 2? What does it mean?
2 divided by 3.
No. Oh, yes. Yes. Okay.
Okay. All right, again, formula, nothing new. You should be using this all your life.
You know,
It's IV.
on top of it.
And so is, oh yeah, Joey, lastly. So this sensible.
So what if I say I want, okay, there is a number 9 pizza. Okay. I want
No, okay, why not?
So what it means? It means now I said
1 divided by 3.
Mhm. All right, so again, make sure you answer your the question is not a sensible idea. All right, because your total current is 20.8, while your fuse is only 15. So your operating current is greater than the fuse. And that should not be the way.
I said 12 something. Then I want 1 form of it.
All right, can Bernice, okay, yeah. Right, so essentially, even if you're operating normally, the fuse will just melt and then the whole circuit will just be cut off. Okay, just a note, I forgot about the part A. Please. All right, you're supposed to write all this since the fuse go on. Let me see. You have to write. Let me see exactly what the question is. Fully describe the function of the earth wire. Yep. So don't miss out this part. You have to describe what the earth wire is for. Actually, it's quite standard. Defect, fault, live wire breaks, touch the casing, earth wire carries the current away. So I think the keywords should be there. Let me underline them. Connected to metal casing. When there's a defect or a fault. If the line touches the metal casing, earth wire carries the current away and protects the user from electrical shock. Again, very standard. Electrical casing, live wire touches metal casing, live wire touches the casing. Earth wire carries the current away, prevents electrical shock. Yeah, very standard answer.
And then 1 out of 10 don't know.
So they ask you to describe the earth wire, so that's all. There's no need to describe the live or neutral.
Yeah, so we technically divided by 10 more. So what is 10 divided by 10?
0.
Okay, what is 10 over 10? That's 10 divided by 10.
All right,
Yeah.
next part. Element in the heater stream of metal use kinetic theory to describe the effect on the atoms as the temperature rises.
Okay, then what?
Joey, what do you write for that?
1 out of 6. What does it mean? What 1 out of 6 mean?
1 is
Good.
6 no.
1 is called wrong.
Okay. Again, there's only 2 marks, so I believe she has already mentioned all the pertinent points. Right, basically,
What?
atoms gain
Okay, I want.
thermal energy.
You can listen.
Alright, so therefore they vibrate more vigorously
I want 1/6 of 12.
about fixed positions.
I want 1/6 of 12. Okay, what?
So nothing particularly new. Now, of course, when they say matter, we assume that it's in solid state. I mean, there's no need to write that, but of course, you have to assume it's in solid state, which is how you can answer in this manner. Yeah. All right, questions? No. All right, let's go on to the last one, I think. Second last. All right, thermostat, mercury. I hope you guys have not forgotten what's mercury. Mercury is a metal, but importantly, it's a liquid metal. And of course, that means it conducts electricity. Now, of course, there's no need to write this in your answer, but this is something you need to know. Okay, what does it say? Suitable value of fuse rating to use for the circuit. Support your suggestion of calculation. All right, Bernice, What fuse rating do you want to use? Or for that matter, you must have calculated current. What is the current from your calculation? Weird number, how weird? 0 point something ampere. Impossible, because look at this. I think the key things will be this. You have actually it's exactly the same formula: power, voltage, and then just calculate your current. The trick is make sure you are using SI units. Power is 0.1, very small. 1, 2, 3, 4, 5 watts. And then voltage is 230.
Okay, then we put in fractions. What is 99 times 9? It's right? Then what if
Okay, I miss anything, no right?
it basically means times 9 divided by 10, so it's the same.
I think I miss almost 0.
Same. The same. It's just in fraction. Of course. You can do times or divide first, it's the same.
Then you should get a very small value for the current. Do you have any signs? Oh no. I got confused. This kilowatts. Alright, it should be the other way around. Oh no. It should be times 1000. Okay, so yep, it's always good to write up conversions like this. Alright, so 1, 2, 3. So you should get 45 volts. And you should get 0 point something. 0 point. Alright, so just be careful. But of course, is there a fuse for this kind of value? No, a fuse is usually a more regular number like 0.2 or 0.25 or 0.5. 196, right? I think I wrote only 106. Okay, so what kind of fuse you get? Obviously larger than your operating current. Okay, so 0.25 will be good. 0.2 will be playing it too close. Of course, you can have 0.3 or even 0.5. That's still okay. Alright, but obviously I wouldn't want to have a 0.2 ampere fuse. Make sure it's higher than that. 0.2 is too close to your operating current. 0.25, maybe that's the minimum. If you want 0.5, will be okay too. Okay, last one. Now again, very standard answer. Kilowatt hour. Okay, the average power consumption of the freezer. Joey, what's your answer? Watts. Okay, yeah, it's 24. No decimals at all. It's 2SF. Oh, okay, fine. When did you get it? 24 watts? Oh, you didn't do it. Come try to follow this is a possible question for you per day. You ought to know it's 24 hours. So power is energy over time. So in this case, energy is 0.58 kilowatt hour. So you divide by 24 hours. You should get your answer in kilowatts. But of course, the question didn't ask what units it ought to be, so you can leave it in kilowatts if you want to.
But this is, you never know, you just got A.
Okay, so if you convert to watts, it will be 24. Okay, Denise, doable. Ah. Alright, the only thing you want to be careful is this is kilowatt hour. So make sure your time is in hour too. That is the only thing to be careful of. And of course, your answer will be in kilowatts. And it's up to you whether you want to convert to watts, since the question did not specify.
So if you want to squeeze it, A.
For me, I will normally write the units in my calculation so as to keep track. What are the final units? Up to you. If you don't like this, then don't. But for me, I include the units in my calculations.
I give you an example.
Okay, questions, anyone? No? Okay, it's not. I thought I had to revise something. That time, Bernice, you were saying you have some trouble with your transfer. So I just quickly go through the heat transfer part. Okay, come. Joey, what are the three mechanisms of heat transfer? All right, conduction, convection, and radiation. Actually, there's one more, but they occasionally it comes up occasionally. In fact, I would say it's rarely. No, can you just add one in, which may or may not come up? Boiling and evaporation are considered heat transfer mechanisms as well. Boiling and evaporation. Oh, make sure you get the three first. Conduction, convection, and radiation.
Once. Okay, once. They were.
Yes.
But occasionally, these are the three. Make sure you know the three first.
Make sure you don't have a yeah, be very kind to the top.
Once in a many years, you may see boiling and evaporation.
What are you finding? Okay. One third one. One by one. Yes, it's opposite, yes. Always that. Find chocolates, find chocolates. What do you find?
Okay, now
You're finding exactly that we flavor. One chocolate, the rest.
The rest are not.
okay, let's start from the basics. Always keep this in mind.
All for the total, right? Found me.
Now, whatever mechanism it is, there must be a temperature difference for heat transfer to take place.
Okay, you have one more and this in total, right?
Yes.
This is the one that you must always bear in mind. And of course, heat flows from high to low temperature region. Always look for your question. Where is the high temperature and where is the low temperature?
Yes. Hey, what you're going to do is I can.
What?
Now, for conduction, it's quite straightforward. Conduction, by right, it can occur in any medium. Get used to this word medium. Medium is matter, M-A-T-T-E-R. Can be solid, liquid, or gas for conduction.
You have alcohol canteen, right? You found 48.
But I especially want you to emphasize when you see a solid, then definitely conduction is the fastest or most efficient. When you see a solid, think about conduction. Okay, heat moving through a solid. First thing to think of is conduction.
Okay, let's tell you.
Perhaps the other thing you want to take note, conduction can go in any direction. Depending on the medium, all right, the medium, it can move from left to right, up to down, down to up, and so on. Depending on the heat temperature difference, it can move in any direction. And occasionally they ask this, which I've seen earlier, right? Now, be a bit aware, what kind of solid are you looking at? Because there's a difference between matter and non-matter. Now, basically for a non-matter, it only has vibrations. Okay, vibrations of particles. So look at your question. Is this a non-matter like a plastic, glass, ceramic? And of course, vibrations propagate through the material. The vibrations start from, of course, the hot region. Atoms will vibrate against the neighbors. Neighbors in turn become vibrate. Of course, they transfer the kinetic energy from one to the other. So vibrations propagate from high to low temperature. Within the solid, of course. But I want you guys to take note. If the solid is a matter, you also have to include free electrons movement. Now, free electrons do not vibrate, they can move through the matter. Free electrons, matters have free electrons. They are free to move through up the matter. That's why we call them free electrons. Now, this is not chemistry, of course, but essentially free electrons are the valence electrons, even though you don't have to write it for physics. The valence electrons are free to move. Okay, can. Now, the other one is convection. Now, check your question. If your question involves fluids, again, make sure you know the word fluid. It refers to either a liquid or gas. So that's a fluid.
How do I find chocolate? They want chocolate. How do you find me? How do you find me?
And I think the answer is quite standard. First, you say that the warm fluid expands. I mean, of course, then that's near the high temperature part. It means volume increases. Of course, that's the meaning of expansion. Then next, you have to talk about density. As volume increases, mass remains the same, density decreases. And this is the words that you have to include. Density decreases. You don't really have to mention about mass, but density, yes, mention about density. And importantly, because of the drop in density, the fluid rises. Okay, it rises as it's less dense than the surrounding fluid.
So how are you?
So this part should also be included in your answer for convection.
Okay.
So the fluid rises.
Okay, we are doing on the second. The concept.
But of course, as it rises, it loses heat as well.
Okay. Some reason. If there's 60 enough, right? If I say 20 is equal, 50 is equal, then how many are not equal?
And the key is, in case you didn't notice, convection only transfer heat from the lower part to the upper part. So I repeat, convection can only transfer heat upwards. It cannot transfer heat downwards. Look out for that.
Oh.
What else? Then the surrounding fluid is cooler, remember? So it means they are denser. And then they sink. The surrounding fluid sinks.
Yeah, just trying to try.
You.
So what do you find out? Oi. Tell you what.
You want to smoke more?
And to make a long story short, okay, I tell you what, I just quickly draw it out because it's a lot easier to visualize it. Okay, so first, this warm fluid rises. Then the cool fluid in the surrounding will sink. And mind you, the heat is only at this portion. This part here is heated up. Now, ultimately, what happens is the rising and sinking. Each rise to cycles or currents. And so in this case, I have drawn two convection currents or two convection cycles.
Okay.
But of course, in real life, it's not so easy to count how many currents there are. All right, so these are the two convection currents I've drawn.
Okay. Next, I'll show you
Clockwise
visually.
anti-clockwise in the left. So make sure you include all these important words. Cycle repeats, convection currents form. They like to see this. Make sure you have convection currents in your answer.
If 30 are how many?
And I believe I mentioned this point. Convection can only transfer heat upwards.
How do you do that?
That means hotter portion is lower, cooler portion is above. It can only transfer upwards.
You see,
So there's a restriction to its direction. Questions, anyone? No?
And if the time total is 9 they add up must be answer. Okay, then.
So in other words,
There's 20.
if I have this here,
Let's just say 5 are red.
look at this scenario.
How many do you want?
I have water, but where is my heat source? Go to the top. Is heat going to transfer from top to bottom by convection? The answer is no. So how does heat move from the top to the bottom? It's not by convection, but by conduction. So take note of this scenario. Occasionally it comes up.
They must add up back to 20, right? So how do I do this?
Yeah, Bernice. Right, just take note of this. Occasionally it comes up by this manner. The heat is at the top, so heat transfer cannot occur by convection. It cannot go downwards. Only conduction can allow heat to transfer downwards.
How do you share within? Usually, the total minus okay. This one minus this is.
So there's no convection here because the heat is at the top.
So I just say you have, you have 100. You share your time. How many here?
Oh my god, tree. Wait. Oh my god, how can you make it was round.
You got 100. You got 5 here, the rest, how many?
Like it's brown. Yeah.
90. If you put 90, if you add it up, you have 95. So we know. Is that final figure?
So that's for convection. Now, lastly, radiation. First thing, now, guys, by now you are familiar with electromagnetic radiation. So when they talk about heat transfer by radiation, we are only looking at infrared because infrared can carry heat most effectively. So take note, heat transfer by radiation is via infrared and not the other ways of the EM spectrum. No, very important. Radiation does not require a medium. It doesn't require solid, liquid, or gas. It can go through a vacuum. And make sure you know what's vacuum, meaning nothing, like outer space. But having said that, even though it's most efficient in a vacuum, it can also operate in a gas or in air. Radiation can go through air rather effectively too. But once you talk about a liquid, then radiation cannot pass through so well. Alright, efficiency of radiation through a liquid is pretty poor. Essentially, the liquid absorbs the radiation and prevents it from propagating. And so,
Because if not even the correct number,
in a solid, even worse, most solids will block radiation except for a few, but you don't have to know those few. Okay, solids typically block infrared except for a few very special solids.
So, how many chapters are there?
So moral of the story, when you encounter a heat transfer question, check your question. Is it talking about solid, liquid, gas, or vacuum?
It's used 14 minus 8. If your cell phones would not get as you write it. I think I see the confusing of cell phone.
Now,
Yes.
just a couple more things about radiation. When you talk about radiation, a few words are important. One is emit. One is absorb. And I assume you know what they mean. And lastly, you also involve the word reflect. So these three words are commonly involved when you answer radiation questions. Emit, absorb, and reflect. Now, my point is this. How do you know something is emitting absorbing. So let's give you an example. Let's say I have a piece of ice. Okay, you have ice here. Question, you have a piece of ice. Is it absorbing or is it emitting radiation? Absorbing, huh? Why? Because
How many filters times over
yes, that is the key. Make sure you know what is the temperature of your object. All right, so if it's an ice, it's at a lower temperature, so it's absorbing radiation. Of course, radiation is going through the air, the surrounding air, of course. Remember, air allows radiation to pass through. So in this case, it's absorption. And perhaps the most important example, and perhaps pretty important example is this one. Sun and Earth, in between is vacuum. I would say the keyword here is vacuum. Once you see vacuum, there's no need to think further. To pass through vacuum, it must be via radiation. It must be. And I think, again, the second obvious point, difference means now the second point I want to make, obviously the sun is much hotter than the earth, so this is emitting radiation. Yes. And of course your earth is absorbing. So always analyze the temperature difference. Who is hotter and who is colder? So what's the difference? Okay. And 96 chocolate, right? That's what they need. So what's the difference? Anyway, in any heat transfer question, you must always look at the temperature difference. You have to think about it. Who is hotter and who is colder? Any, not just radiation. Okay, what else about radiation? 4 factors affect radiation. You cannot take smaller minus big. Okay, but still, you don't need anything about it. You're gonna say that one. You did. At least one.
No.
Yes. Right. Venice, can you remember the 4 factors that affect radiation?
It was so crazy.
Temperature, yes. What else? Color, yes, good. Matters. Not so much. But let's go through them. 4 factors: color, texture, temperature, and lastly, surface area. Yeah, they like to ask about these 4 factors. I mean, not all of them, probably some of them. Especially color, they like to ask about color. Okay, this only apply to radiation now, these 4 factors. Right. So black is the best what? Emitter and absorber. It depends on the temperature. Something that's good at emission is good at absorption also. Make sure you understand this part. Okay, take note. Emission and absorption, they work on the same factors.
Very interesting. Very interesting.
Of course, the reverse is true. What is the poorest absorber and emitter? Texture is about whether it's rough, smooth. Of course, rough is the best in terms of emission and absorption. Okay. So again, whether it's emitting or absorbing depends on the temperature versus its surroundings. Temperature, of course, they know exact surface temperature.
My pressure is very bad.
Yeah,
I don't know.
that's not the pay to roommates.
No, why is your pressure then? That's not my pressure.
It's a. The
I reckon this.
all is like.
Oh,
Right, so higher the temperature, stronger the emission, and the reverse is true. Lower the temperature, stronger the absorption.
Three.
I'm not sure. So how you think that is? Because people do.
Well, this one, you find black, but you find white
Right, I think the last part is quite easy to visualize. Larger the surface area, stronger the emission or absorption, depending on the conditions. Right, so if I look at something like this, I have two objects, similar size, similar color, similar texture, but one is higher temperature. Obviously, this one will give you better emission. Right, and of course, in both cases, they are emitting because the surroundings are of a lower temperature. Okay, so always think about the surroundings as well. So both of them are emitting, just that the 100 degrees Celsius object has a better emission because it has a higher temperature difference compared to the surroundings. Okay, on the other hand, right, same thing. If I have this object here and you colored it black, so obviously it's going to emit radiation very well. Okay, it's hot, so it's emitting, of course. But on the other hand, if this object is not hot, it's cold, well, if you absorb radiation very well as well, because it's black. But don't confuse with this. On the other hand, if I have a cool object here, all right, and let me see, what was I trying to say? Oh, this is about reflection. Let me just go something else. Okay, last part, reflection. When do we talk about reflection? Now, why is something a good absorber? Because it absorbs everything. It doesn't reflect. So a good absorber is a poor reflector. Now, on the other hand, a poor absorber is a good reflector. So try to understand this. It doesn't absorb, instead it reflects. So they are actually different sides of the same coin. Absorption and reflection.
You read the first page, you sure or not?
So just take note of this absorption and reflection. Occasionally, they will ask about reflection
Then you find you. Then.
of radiation, of course.
Then. Yeah.
Find one out of six.
You find blue first. How do you find blue? 1 out of 6 for them, right? 1 out of 6 for them.
1 out of 6.
Wait, how do you find that from? Hey, how do you find blue? Yeah, blue. No, wait. So this.
And remember, good absorber is good emitter. Good absorber is a good emitter. So that also translates to a good emitter is a poor reflector. I mean, in reverse, poor emitter is a good reflector. All right, so that's how you connect the three words: absorb, reflect, emit. They are all linked together.
I want people what the difference mean. Yeah lah, you only find the blue plan means we have the
One example. First thing, if I have a cool object surrounded by air, you can safely conclude that it's absorbing radiation because it's cool. But what if I colored it white? If I color this object white, it doesn't absorb so well. Remember, white color is a poor absorber. So instead, most of the radiation is reflected. So take note. Cool white object doesn't absorb well. Instead, it reflects well. So try to follow this logic here. I mean, likewise for a shiny object, it reflects well, doesn't absorb well.
You have 15, right? Then the rest of the total is 6.
But it must be surrounded by air or vacuum,
Total minus 3.
of course.
Yeah. Okay.
Let me see. So I need to. Any questions from anyone?
The total is 6, right? The blue.
No, Joey.
Black and red.
Because okay, of course, this one last point. Radiation can occur in any direction. It just depends on the temperature difference. All right, it can occur left to right, right to left, up to down, down to up, depending on the temperature difference. Okay, otherwise it can occur in any direction. Okay, I think that's about this for this. I mean, that's a crash course on heat transfer. Let me just pass you a
It's very reading one.
Okay, I know you are very busy holidays, so I just tell you to do the MCQs, but bring it along next round. Okay, for now, just start with the MCQs.
Okay, first one, first answer. Okay, read the first answer. What do I want? So how do you find it?
Isn't this?
Oh. Okay, you found 72.
9 minus 7 is what? 2 and 2 minus 1. 1.
And 2 what?
This is not answer. Okay.
Okay, that's 6 pizza, right? Each pizza is 1. So one pizza, 1 pizza.
How is 1 minus 1 1?
It's 6 of them, so it's 6.
No.
So how many slices are there?
7
Times
minus 2.
So what is
2 minus 1 is 1.
Okay, why do you tell me this? What is this? You can tell me what is this. You just have to explain if what is that word mean. Like you use it, you feel what is 72? Mm-hmm. Then why do you recommend it? When you saw the answer, right? Try to go step by step, no rush. What? Show me something. I'm not thinking. Wait. Wait. Is it 8 or 18? Oh my god. Both looks both songs okay.
80, right?
What's wrong? What is it? Oh, minus only. Just minus 1. And this we have this. Minus 1 by 1.
Please minus 2.
It's 6 minus 2 minus 6.
Then 4 minus 6 is
What's that like that?
4 equals 6.
Yeah, do like you don't step by step. Don't go minus by 6 times. Come on. It doesn't work.
6 minus 2 is
It's slowly. So you count as how many sizes are there? Okay. Then 1/4 of them are even. Then the rest are not even. Right? So how do you move not even? Actually. Try also. Hey, you guys very funny.
Oh, wait.
You minus away this thing or what? You minus away black pen. This one, you minus away black pen, right? You got blue pen, right?
Hey, shit.
You got blue pen, right?
Ah, 1. It's 10 lah. It's 14.
1. Then minus away. Blue is how many? 16, right?
Minus 6 and minus 2 is 4. What is that?
Which one not?
96.
One word.
Minus 72 is right to me.
One not. Minus away. Yeah, how do you guys get it?
He got it correct.
Okay. Minus 96 minus 92, right? Equal 24, right?
Wait, correct.
Yeah, I don't know how to get 18.
Wait, then I do again.
Wait, why you confused from? Why you confused me?
What's that minus 2? I got 4.
How do I want?
Then 9 minus 7.
You get 8 or
No.
respect.
Because 9 is still minus 7.
Now you might become 24. You see? 24. 8 minus 7 can be 18.
But how is it? 8 minus 7 is 1.
96 minus 22 is 1.
6 minus 2 is 4.
The other one is 2. 24, right?
No.
Huh? 9 minus 7 is.
9 minus 2 is 2. Then why is 8? 8 minus 7 is 1 then. 8.
Yeah, so it's 24, right? First. Then you minus 8. Then.
No, but 9 still can minus 7 is 2.
Yeah.
But why is it put 8?
Yeah, I don't have to apply this one. The minus of all and form. We check. So how many are? Okay, what is 18?
Oh, yeah, 8. There you go. I changed my mind, so it would be
To find
what? I'm keeping runs.
to find what?
Go.
Oh, one. Okay.
Go now. Yeah. Calculation. Wait, what?
Convenient.
No,
Convenient.
no.
Right.
What time is it? What time is it?
Okay. 18 is what?
Have you finished the MCQs? Okay, let's at least go through the MCQs. Make sure you get all of them correct. Okay, number one, best absorber and emitter. Yeah, Bernice. Huh? Which one? Okay. Yeah, you should get it. Dull and black, dull and black. Well, number two, water at the bottom stays cold for some time. Alright, why is this, Joey? Yeah, yep. Water is the tall conductor of heat. Notice heater is at the top, so convection does not occur. So heat goes downwards by conduction. And I think I mentioned conduction does not propagate well in a liquid, correct? It's the strongest in a solid, not a liquid. In general, liquids are poor conductors. I mean, unless it's a special case like molten metals and so on. Alright, so anyway, nothing much to argue here. Number three, what is the correct order? Yeah, yep. Make sure you get C. I think no need for me to elaborate. This is the same question of your battery, so I'll skip it. Okay, number five, let me get it right, Joey. Yes, nowhere did we mention about air pressure. So, yep, guys, bring this along next week. We'll continue with the other questions. Any final question for today? No? Okay, good. Then we shall end here.
The one I still use it. What I open, see my Starbucks for all problem. I don't know. What I still use. I still use it one. Eight. Or what? Or what? I see you. And so. That's it. I'm supposed to see it. What is that? It.
So that's different. Okay. How do you run the delivery? What's the distance? 1.4.
My school one is 1,000 meters. My mother's friend, it was so slow. What I meant.
Right.
Okay, bye bye. Yeah,
Oh, yeah, friends.
no,
Yes, I'm giving them.
for what?
Please.
No,
Yes. Even you guys move.
for what? What? Why? Why? I don't know. Why?
And I have to.
Why? Why do you need to go out? Oh, my father go buy my.
Wait, come back.
Three.